Everyone, so we're just doing some revision of and preparation of the control test for 2025. We are revising by going through an old control test of 2023. So this is quite a nice reflection. The topics that will be covered is exponents and surds. There's some instructions. Now if I quickly run through this instructions, instruction number 2 is quite important. You need to answer all the questions. Then further, clearly show all calculations, diagrams and graphs that you have used in determining your answers. Some answers only or answers alone will not necessarily be awarded full marks. So you can't just go write x is equals to 5 and expect to get the full answer there or to get full marks. An approved scientific calculator like this one will be, you may use that. Then if necessary, answers should be rounded off to 2 decimal places unless stated otherwise. They can ask you to write it in simple assert form, then you leave it in simple assert form. You need to read each instruction individually. Diagrams are not necessarily drawn to scale. This is will not be applicable for tomorrow because this test doesn't have any sketches yet. Number your answers correctly according to the numbering system used in the question paper. It is in your own interest, and that should actually benefit. Interest should be benefit to write legibly and present your work neatly. Sometimes learners write the right answers, but I can't make out. It looks like spider webs and stuff like that. So if I see a spider web and I'm looking for x is equals to 5, but I see Spider-Man and all of the different stuff here, I'm not going to mark your answer correct. Simplify, read that question carefully, simplify without the use of a calculator. Now if we see this type of question, we need to show and indicate all of our steps. And we write all answers with positive exponents. I'm not going to go through this one because we did cover this in the Controll class test. Maybe I should cover it because a few of us didn't get that answer right. Let's quickly go here to the side and see if we can do some, provide some answers. Then just set some lines there for us. Who can help me with this one? So the expectation here is, now I want you to write clearly. I'm going to start and try to write for you guys. So here we have 1.1.1. 1.1.1, and then I'm going to write square root. I would advise square root of 3, that is nothing. So there's actually a dot there, but a dot means multiplication, a to the power of negative n over 4, and that is squared. Now, first thing that I'm going to do here, I'm going to start with my answer, that is the instruction. So I'm going to get rid of the square root. How do I get rid of the square root? I divide the exponent by 2. So that's going to be 3 to the power over 2. Multiplied with, now I'm going to use the power to power rule. So I'm going to say a to the power of, let's do that to the side here. So that's going to be n over 4 multiplied with 2 over 1. So that one and that one cancels out. There's a 2 left there. So I actually have a to the power of negative n over 2. But I also take note that there's a negative 1 there in front. I don't write it down, but I'm just, for explanation purposes, I'm putting it there. So the next step will be, now I have the bases that are the same, and what I'm supposed to do if I'm doing multiplication of, I add the exponents. So it's going to be a to the power of 3n over 2 plus negative n over 2. But that plus becomes a minus, so it's going to be just n over 2. Then my answer simplified here is going to be a to the power of 2n over 2, and then my 2's cancels out, so my final answer is a to the power of n. So that one wasn't too difficult. The next one there is question number 1.1.2. 7 marks up for grabs there. Why? Because the memo is set up that they normally give you marks for doing prime factorization. Now I'm going to show you a quick cheat if you didn't know this. The numbers there that we have is 54. Yeah? So you type in on your calculator 54, you type in equal sign, you type shift, and then you type factorization. Is it that one? I can't see. That one? Next one? So, no. So let's try again. Shift. And then So then I'm going to write this 54 as 2 times 3 to the power of 3. Then I'm going to prime factorize 18. How can I prime factorize 18? 9 times 2 or 3 to the power of 2 times 2. Then there is minus 3 to the power of n multiplied with 3 to the power of 1. Underneath I have 3 to the power of n. Let's multiply that out. 3 to the power of 2n minus 2 and then multiplied with 3 to the power of 2 times with n, like that. Now I ask myself, how many terms do I have in the numerator? Yes? Say it again. Oh, so there's an n there. Is that right? Okay. 18 also has n minus 1. Thank you for that brackets there. Some of us did do this, so I can see. Thank you for that. Now we're going to go, and what is our next? So the first step here is actually for get accredited for doing the prime factorization. That's the first mark there. So then after I've done the prime factorization, I'm going to do the power to power rule. So that is going to be 2 to the power of n multiplied with 3 to the power of 3n minus 3 to the power of 2n minus 2. Careful for that one. A lot of learners don't get that one.
Isn't it the top there times 3 to the power of times 3 to the power of n plus 1?
Is it plus 1? Let me just check. No, that's the second one. You see this one? No? How do we get to that? Plus 1. How do we get to that? Let me just explain that quickly. So, if I rewrite this, what is the exponent here? 1. So then that means if I rewrite, bases are the same, so I can write this as 3 to the power of n plus 1. But I broke it up into 2 bases. So that's actually the explanation as to where that comes from. You understand? Now I'm going to have minus.
In front of the 3 must be a times or a minus.
Is the multiplication. Okay, thank you. So there should be a multiplication there. Is that better? So we have a multiplication there, so that's going to be 3 to the power of n. Did I skip the 2? Okay. So that's going to be times with 2 to the power of n minus 1. But let's split that up. Okay, let's leave it like that. N minus 1 and then 3 to the power of n and 3 to the power of 1. All over 3 to the power of 2n. Let's split this up. 3 to the power of negative 2 multiplied with 3 to the power of n and 2 to the power of n. Okay. Now the top part I cannot go cancel out yet. Why not? Because there's separation in terms. So what is a common factor that I can take out there? 3 to the power of, check carefully, 2 to the power of n. We all agree on that. And then I'm going to take out also 3 to the power of 3n. Why am I taking out 3 to the power of 3n? Because if I add up, you're going to get 3 to the power of 3n. So, okay, I'm going to do another, before I get to this step, because that's going to cause confusion for you, let me just explain. So that's going to be 2 to the power of n multiplied with 3 to the power of 3n minus, now where's my, if I take this 3 and I'm going to say 2 to the power of n minus 2 and then there's another 3 plus n and then I have plus 1. Then I have 2 to the power of n minus 1. Like that. So I'm going to split up this term quickly. Let's do the simplification here. So that is going to be 2n and n is equals to 3n. So can I correct this here? So that's going to be 3n, no? And then minus what? Minus 1. And then here I have multiplied with n, 2n, and I'm just going to write it like that. That's multiplied. Are we all in agreement with that? Yes. I didn't make any mistakes yet? Okay. All over, now I'm going to do the same at the bottom. 3 to the power of 2n minus 2 plus n. And then times with 2 to the power of n. And what does the bottom give me? 3n minus 2. So let's just correct that quickly. That gives me 3n minus 2. We are all in agreement with that? Okay, now I go on and I'm going to say, so in the top, what do you see as a common factor? 2 to the power of n and 3 to the power of n. Thank you. 3 to the power of n like that. Then I'm going to take, there's the first term, or this is the first term, and then this is the second term. So it's going to be 1 minus 3 to the power of negative 1 multiplied with 2 to the power of negative 1. All over, let's split this up now. 3 to the power of 3n times 3 to the power of negative 2. And I'm going to put a 2 in front, so that's going to be 2 to the power of n like that. Another nice thing of this is that one cancels out with that one. This one cancels out with this one. So it's basic grade 8 and grade 9 mathematics now. We have 1 minus a third multiplied with a half. Let's put it in a bracket, or let's keep it in a bracket. Over what? Over 1 over 9. Let's do the simplification here. So I'm going to have 1 minus 1 over 6 all over 1 over 9. So I can simplify this further. I can say 1 is actually 6 over 6, and that gives me to 5 over 6 multiplied with the reciprocal 9 over 1, and then I can say that is going to be 45 over 6, or I can say, but that 6 cancels out, and what is the number that can go into 6? 3 goes into there twice, and it goes into here 3 times, no? So what do I basically have? I have 5 times 3, which equals to 15 over 2, and that can be written as 7.5, or you could have left it like that. 15 over 2 is your answer there. Okay, so nice question there. Definitely going to be something like that in tomorrow. So I'm not going to do all of the questions because of time's sake. I think we have done enough of this one. 1.2, just look at that one. So let's look at 1.2 here, guys. No? So 1.2, what I would do here for myself, let me just see that question, 5 to the power of, you see that one? I'm going to choose the smallest one here. No? 5 to the power of 297. This question says, without the use of a calculator. And you can go type it into a calculator. Your calculator might not even get you to that answer because your calculator is not as smart as you are. You cannot use, but I suggest, because I know you're going to take, we're working on time, because I know time is a problem for you. Where do I encounter learners not finishing their test is because they write in pencil first and then in pen afterwards. Please don't do that. No? If you make a mistake, like I told you, write in pen from the start, because there's not enough time to rewrite. I'm going to do this one, but I'm going to go straight to the answer quickly. Help me out here, guys and girls. Let me just first write down this question. So remember when they say this, show, and they ask you that you should get to that answer. For a minute, please forget that answer. Keep it closed. Don't even look at that answer. Ignore it, because that answer is going to confuse you. Simply just think about what you can do here with this. So what I would do here, I would say for myself, I'm going to write down the question number 1.2, and then I'm just going to copy the 5 to the power of 3001 minus square root of 5 to the power of 2997 all over, are you going to see where I'm writing now? All over 5 to the power of 299. Okay, let's see if we can go there. Excuse my handwriting, I struggle to write on this screen. Right, so now we have here. So I choose the smallest one, and I'm going to break up the first one so that it looks like the second one. So how do I get to 3001? Who can tell me from 2997? How can I get to 3000? Plus what? Plus 4. Minus 4. Okay, so let's rewrite this one. That's going to be 5 to the power of what? 2997 multiplied with 5 to the power of 4. And then I'm going to write this. I'm going to keep this like this. So that's 42997. And then I'm going to rewrite the bottom one as square root of 5 to the power of 2997 times with 5 to the power of 2. Do you see a common factor there? Let's take out the common factor. So the common factor is the square root of 5 to the power of 2997. And then I'm going to open a bracket. What is going to remain? The square root of 5 to the power of 4 minus 1 over to the power of 2997. And then I'm going to write it as a separate, but it's still going to be 5 to the power of 2, like that. Now the nice thing about this is, because there's only single terms, this one and this one cancels out. Then I'm left with 5 to the power of 4, but I want to get rid of the square root. So that's going to be 5 to the power of 2 minus 1 and 5 to the power of over 5. And then I get 24 over 5. So, nice question there. This question, prime factorize, no? And then remember, if you want to get how do we get rid of the roots? We take the index outside and then we divide the exponent by that. Let's go this one. Easy. That one, easy. This one is easy. This is the question here. Okay, let me see what we can do here. You see, once again, this is now prime factorization. So, we need to figure out x to the power of what? X to the power of x. But that one and that one needs to be the same. Now this is a higher order question. This is your level 4 type of question. For tomorrow's test, I didn't see any of this. This is basically where we use a little bit of the maths that we know and we test you with something that isn't so straightforward. So what I would do here, let's see. And this is not the question, but this is the type of question that not all of the learners can answer. But this is the questions that separates a 90% learner from an 80% learner. So your 80% learners normally that can do all of the stuff that we do in class and that we cover in class. But if you want to get that 90 up until the 100, this is the type of questions that you are able to solve. Okay, so let's go rewrite this part here. If I want to rewrite 2, and I'm going to use my calculator with this one, I'm going to write 2, what is that number? 2048. And I'm going to try and shift and prime factorize that. So that's 2 to the power of 11. No? So that's 2 to the power of 11. Now you see here, here's my train of thought. How can I write 2 to the power of 11? I need to get to a number here where this number at the bottom, which is x, and that number is going to be the same. So I write it as 2 to the power of 2 to the power of 11. But how is another way I can write? Let's focus on 2 to the power of 11. How can I rewrite that? I can write it as 2 times with 2 to the power of 10. So that means that becomes now 2 to the power of 2, which equals to 4. And then I keep on doing that the whole time until I get here 2 to the power of 6 and there as well 2 to the power of 6. And then that means 64 to the power of 64, because that's 2 to the power of 6 and 2 to the power of 6 equates to x to the power of x. So that's a what do you call it? A brain breaker key. So that is a little bit, but there's the train of thought. You can copy that. Just remember it's 2 to the power of 11, but now each time I'm going to write that so that I can get the base here the same as the exponent. So I keep on breaking it up, and I go through my thought process there, and I get closer and closer there. There I start with 11, then I get to 10, then I get to, that spot is there, 9, I keep on with that process going on like that. So I'll give you a minute or two just to copy that, to write it down, take it into your books. There will not be a question like this in tomorrow's paper, no? Because if you look at this paper was set out of 50 marks, no, 70 marks. So the moment when we go above 50 marks, then we need to say, okay, but we're going beyond what we covered only in classroom. But this is not actually beyond the classroom, this is actually incorporating the knowledge which you have. So this is a higher order question. There's not any of that in tomorrow's question.